let's go ahead with a quick overview of the Canvas or AWS Academy. So once you have this, once you log in, you should be having this view in front of you. So once you have this view in front of you, you can go into each module. And then once you go into each module, you're going to see each section. Uh, each section might have video. Some sections might not have video, and it will be kind of a slideshow. And you're going to go through it one by one. And at the end, you guys have what's known as the student guide and the knowledge check. The knowledge check, you're going to have that at the end of each module, okay? And that's what I want you guys to go home, and after every class, I want you guys to go home and complete that module check. And it's going to be like a test preparation, and it will prepare you for the test. You have to score at least 70% on this to finish the course. So do not worry if you don't get 70%. You could also always retake it. Okay. So this is what is going to help you prepare for the test. It's going to have a lot of questions. Each knowledge check has 10 questions, and you should score about 70% on it. The student guide, if you click on it, here you're going to have the lectures and the slides for the class. So these are the slides. So, as you can see, these are the slides we're going to be covering. So you can always go back home, read them over. We're going to be covering them in class, but you're going to go home and read about it again. Now, there's also the videos you're going to see under each section, okay? So you're going to be watching those videos, and as you go into each video, once you finish it, you could always say next. So you could always go to the previous one, and from there, once you finish it, you could go to the next one. And I would suggest all of you guys to first take it step by step. So you watch the video, get a quick idea of what it is, and then you go ahead to the slides and read through the slides and go through them. Once you finish that, then you have to go through the knowledge check, okay? So that is a quick overview of how to cover the modules in the Canvas or AWS Academy. So now I'm going to go ahead and get started with the class. All right, so I'm going to go ahead and start the video over.
Hello, and welcome to AWS Cloud Foundations Module 1. This is called Cloud Concepts Overview. This module addresses the following topics: Introduction to Cloud Computing, Advantages of Cloud Computing, an Introduction to Amazon Web Services, and the AWS Cloud Adoption Framework. In addition to this video, there's going to be a knowledge check that will be used to test your understanding, the key concepts that are covered in the module. After completing this module, you should be able to, number one, define the different types of cloud computing. Number two, describe the 6 advantages of cloud computing. Recognize the main AWS service categories and the core services. And finally, review the AWS Cloud Adoption Framework. We're ready. Let's get started.
Woohoo! All right, so that was introduction, and now you guys have a quick idea of what to expect in this module. To get started, we have the cloud computing.
Hello, and welcome. This video will cover an introduction to cloud computing. What does cloud computing mean to you? Take a moment, think what cloud computing means to you, and write a short sentence. Cloud computing is the on-demand delivery of compute power, database, storage, applications, and other IT resources via the internet with pay-as-you-go pricing. These resources run on server computers that are located in large data centers in different locations around the world. When you use a cloud service provider like AWS, you are using the computers owned by that service provider. These resources can be used together like building blocks to manufacture solutions that will help you meet your business goals and satisfy technology requirements. Cloud computing enables you to stop thinking of your infrastructure as hardware. Instead, think of it as software. But what does that mean? In the traditional compute model, infrastructure is thought of as hardware. Hardware solutions are physical, which means they require space, staff to maintain it, physical security, planning, and a capital expense. In addition to significant upfront investments, another prohibitive aspect of traditional computing is the long hardware procurement cycle that involves acquiring, provisioning, and maintaining on-premises infrastructure. With a hardware solution, you must ask if there's enough resource capacity or sufficient storage to meet your needs. And you provision capacity guessing theoretical maximum peaks. If you don't meet your projected maximum peak, then you pay for expensive resources that stay idle and don't render you any benefit. If you exceed your projected maximum peak, then you don't have sufficient capacity to meet your needs, and your customers do not receive the service that they desire. If your needs change, then you must spend the time, effort, and money required to implement a new solution. For example, if you wanted to provision a new website, you will have to go out and buy the hardware, rack, and stack it, put it in a data center, then manage it, or have someone else manage it. This approach is very expensive and time-consuming. By contrast, cloud computing enables you to think of your infrastructure as software. Software solutions are flexible. That means that you can select cloud services that best match your needs, provision them, and terminate their use based on your demand. You also pay only for what you use, when you use it. You can scale resources up and down in an automated fashion as a way to expand and contract your deployment in order to meet your customer demand. With the cloud computing model, you can treat resources as temporary and disposable. The flexibility that cloud computing offers allows businesses to implement new solutions quickly with very low upfront costs. Compared to hardware solutions, software solutions can change much more quickly, easily, and cost-effectively. Cloud computing helps developers and IT departments avoid undifferentiated heavy lifting work like procurement, maintenance, and capacity planning. They also enable you to focus on what matters most, which is your business and its improvement and evolution. As cloud computing has grown in popularity, several different service models and deployment strategies have emerged. This will help you meet your specific needs for different users. Each type of cloud service model and deployment strategy provides you with a different level of control, a different level of flexibility and management. Understanding these differences between these cloud service models and deployment strategies can help you decide what set of services is right for your needs. There are three main cloud service models: infrastructure as a service, platform as a service, and software as a service. Each model represents a different part of the cloud computing stack and gives you a different level of control over your IT resources. First, infrastructure as a service are the basic building blocks for your cloud information technology and typically provide you with access to networking features, computers, whether it's virtual or dedicated, and provide storage space. Infrastructure as a service provides you with the highest level of flexibility and control over your IT resources. It is most similar to your existing implementation that many IT departments and developers are familiar with today. Platform as a service removes the need for you to manage the underlying infrastructure. Usually this relates to the hardware and operating system. It does it through automation and allows you to focus on the deployment and management of your applications as opposed to the provisioning. Software as a service provides you with a complete product that is run and managed by the service provider. In most cases, software as a service refers to end user applications. With software as a service, you do not have to think about how the service is maintained or how the underlying infrastructure is managed. You only need to think about how you will use that particular piece of software. A common example of software as a service is a web-based email application where you can send and receive email without having to manage the server, the email product, or maintaining the operating system in that email system. There are three main cloud computing deployment models. Each of these represent the cloud environment that your applications can be deployed in. A cloud-based application is fully deployed in the cloud in the all in the cloud type of implementation. All parts of your application will be running in the cloud.
Can you
Applications in the cloud have either been created in the cloud or have been migrated from an existing infrastructure. To take advantages of the benefits of cloud computing, your applications then can be built on low-level infrastructure pieces, or you can use higher-level services that provide abstraction from the management, architecting, and scaling requirements of your core infrastructure. In a hybrid implementation, the deployment is such a way that to connect your existing infrastructure and applications to a cloud-based resources. They're not located in the cloud. They're located in your physical facilities. The most common of this hybrid deployment is between cloud and existing on-premises. This extends and grows your implementation while connecting cloud resources to your internal systems. Finally, on-premises. Deploying resources on-premises use virtualization and resource management tools, sometimes called private cloud. While on-premises deployment does not provide many of the benefits of cloud computing, it is sometimes sought for its ability to provide dedicated resources. In most cases, the deployment model is the same as a legacy information technology infrastructure, while using application management and virtualization technologies to try and increase resource utilization. There are many similarities between AWS and a traditional IT implementation. First, AWS security groups and network access control lists are similar to firewalls. AWS identity and access management is similar to user provisioning and access control list. Elastic load balancing and Amazon Virtual Private Cloud represent your cloud networking infrastructure, which compares to routers, network pipelines, and switches. Amazon Machine Images are used to initialize Amazon EC2 instances. They're similar to your on-premise virtual servers. Amazon Elastic Block Store represents a hard disk that attaches to your virtual machines and is equivalent to a direct attached storage. Amazon Elastic File System also attaches to your virtual machines, but it represents a traditional storage area network. Amazon Simple Storage Service, or S3, provides the ability for you to store files using the internet and is similar to network-attached storage. Finally, Amazon Relational Database Service is the equivalent to your physical relational database management system. So pretty much everything you will want to do with a traditional data center is available with AWS. Thanks for watching. We'll see you in the next video where you will learn about the advantages of cloud computing.
All right, so that was a little bit of too much information. So let's break it down and get into it, okay? We're gonna go ahead and see what is all of that different things mean, okay? So the first thing he said and he talked about was the cloud computing. And what does cloud computing mean? It's basically instead of having your traditional databases or traditional IT infrastructure on a premise where you have your infrastructure and resources from servers, from hardwares to firewalls, where you build your servers, where you have your routers, switches, everything that we talked about previously in the IT fundamentals class. Instead of doing all of that as a hardware device, as a physical device where you could feel, touch, have a storage room for, you would use it as a software. Now, instead of going to a traditional software, everybody heard, I believe, when people were starting back in the day in before Amazon. So when Amazon started, I believe you guys heard that he started it from a garage. So what happens is when he's starting it from a garage, he actually has physical computers that are sitting in his garage that are 24/7 on and 24/7 connected to the internet. And those are receiving requests, sending back information. But all of that physical devices are located in his garage or maybe in an office setting, or that's not a garage, but that was Amazon example. But he will have in an enterprise level, you will have something known as a server room. Those server rooms are where you have your servers located. But now, what happens if your business jumps from 1 million users to 5 million users the next day? You would have to buy 100 more servers and have to connect maybe 100 more switches or routers and everything. Now that is very hectic. That was used to be done before, and it's very hectic because now you have to actually get physical stuff and connect them. The cloud model helps us to change all of that to by few clicks and few configuration using it as a software. You could grow your enterprise or your customer base from a million user to a 10 million user with a simple configuration of few clicks. That's how easy the cloud module makes it for us. And that is what it means to think of it as a software infrastructure. Instead of thinking it as of a hardware, you think of your infrastructure as a software. And that's what it means, because you're going to change all of those hardwares into a bunch of few clicks and few configurations in the cloud.
But there's still hardware is managed by
But
AWS.
by AWS, and that's where we're going to learn about the responsibility module, and we're going to come to that. There's a responsibility module when it comes to the security, uh, which means you are responsible to secure the software, and AWS is responsible to secure the hardware. So you're gonna make sure your application that is running is secure. They make sure nobody gets into the network to your servers. But we're gonna come into that once we move into the cloud security. So now we saw here traditional computing has infrastructure as hardware. We want to look at infrastructure as a software, and that's one of the modules we're going to talk about. So there's three different modules: infrastructure as a software, you have platform as a software, and then you have a solution, software as a solution, service, infrastructure as a service, and platform as a service. So what does this mean? Infrastructure as a service. If anybody used before to deploy a website using Heroku or something like that, or if anybody is familiar with the AWS, you guys have something known as EC2, right? Those are infrastructure as a service. Why we say it's infrastructure as a service? Because your EC2, which stands for Elastic Compute Service, is basically computers. You have basically computers that are running on the cloud that is managed by AWS, and you get to use them as desired as you go. So what happens is now the infrastructure you was going to build before in your enterprise level, now that turns into a service provided by AWS, which is your EC2. Another thing is platform as a service. Platform as a service is where you could go ahead and do a bunch of stuff. Like if you guys have heard of Beanstalk, the people who were in the class before, AWS cloud, AWS has something known as the Beanstalk. It has something known as Light Sail, and those help you to deploy your applications using a software, basically a software. Instead of building a whole infrastructure to host something, to build something, to deploy something, now it's all done using just simple clicks and simple configuration. Now, next thing is software as a service. Now, the software as a service is something we all are very much familiar with. A good example of a software as a service is your Netflix account. I believe everybody here has a Netflix account. Those Netflix is basically a software as a service. They are offering you a service to watch, stream movies, use all of that. That is a very good example of a software as a service. Another one is your Gmail account. All of those are software as a service. Now, what happens is as you move from an infrastructure as a service to software as a service, you your IT resources and the stuff that you would need, the dependency goes less and less and less. So what happens is the more you need to control, more resources you have, the more that's the infrastructure you're building. Now, as you move more towards the software as a service, your dependency on those actual resources becomes less, and because you have much less control over those resources, like your Netflix account, you only have access to only your account. Your Gmail, you have access only to your account. You have access to nothing else. That's how those different modules work. Now, to understand why would we need something like this, what this would help us in the real world. So in your real world, once you want to build a, a solution, you have some kind of problem and you want to build a solution to it. And that solution could be anything. For let's take Uber as an example. Now, to build the Uber service, you would need infrastructure, and that infrastructure you would have to get it yourself, configure it yourself, build it yourself, buy it, maintain it. But if you use AWS, you could have that infrastructure built on the AWS account. But now what happens is those are being managed by the Uber company and they will be managing it. But for the end user, they will still be using it as a software. But for the company Uber itself, that would be an infrastructure as a service to them. That's how it would have a contrast between you as an end user and the business owner. Now, moving to a platform as a service, what would happen in a platform as a service is where would you have your users come in and your users request ride shares or something like that. So now you would have an application running. And now that application is your platform of getting users and connecting those users of yours to the software as a service that you're providing. So it moves from one model to the other one as it goes by from a different business needs perspective. So whatever your business needs are, it will move from that to the next one. We also, oh, sorry, I'm going back. Now, there are different deployment models that we saw in the video. So you have your cloud deployment, which is 100% of your services that you are allocating are all 100% running on the cloud. And then you have something known as hybrid, where you have, for example, 50% of your resources are running on the cloud and 50% are running on your premise. Uh, that is something where you want to have, maybe if you have a very sensitive business data, or maybe not even sensitive, but that business data by law requires it to be in service in your own servers or in your own hardware. For example, maybe some government body, or let's say any government offices or something, they would require probably some of those records to be with them all the time, and they should own it. Because the cloud, you do not own it, you would have somebody else. So you could have it dedicated and the non-dedicated, and we're going to look at those once we move into the more into the EC2. But what happens is in the hybrid, sometimes you would have resources that needs to be in your own premise. And now, once you have your resources on premise, but then you also have some other resources that are running on the cloud, you would always want to have some resources running in the cloud to decrease as a business. You would always want to have want to decrease your capital expenditure. You don't want to have 100 servers running. Maybe if you have, depending on the business need, if you have a business need that needs just to have people's identity only, depending on the business policies, if you have only identities, you want to have it stored in premise, you could have two or three, depending on the customer base, that many servers located on premise, and then 90% of your other premise servers will be on the cloud to run uh, basic input output functionality, request response, and all of that. And then you have something known as the on-premise, where you need all your information. So a good example of something like this is the CIA. CIA is one of the customers actually of AWS. So CIA is a customer of AWS. What do they do is they have their AWS systems and softwares and everything being run on premise, but they're using it as a virtualization model. We saw how virtualization works previously, and that's how they will have it. They will have it in a virtualized form running on their premise. Uh, People who were with us in the IT fundamentals class, we talked about many different things. We talked about firewalls, and then ACLS, which is access control list, where you control the list of people who could have access to some kind of server you're running or some kind of information that they need to retrieve. Now, instead of in the traditional world where you have firewalls, in the AWS or in the cloud, you would have something known as security groups. Or we also have network ACLS, where they help us do the same functionality, but as a software, and it's being managed by AWS, and it's just as simple as having few clicks and configuring it. In a traditional world, we have administrators that have access to, they have the right to do anything. So an administrator would have a right to read, write, delete records. In the AWS, you have that set up by something known as IAM, or it's known as Identity Access Management, and that will help you give different access to different people depending on their roles. So in a business setting, you'll have a company and you'll have a person as an administrator, you'll give him full rights. Person that is just a worker or maybe a help desk, and you'll give him limited access, and you'll manage those access. Instead of having, before you will have your administrator, you will have and then you'll have this different users and everybody having different privileges. You could still do the same thing using IAM in the cloud. We also saw network routers, switches when we were talking in the fundamentals class. Now what happens is in your cloud, you don't need routers. You would actually use something known as load balancing. And the load balancing is, we talked about load balancing, I believe, in the fundamentals. But what happens in the cloud, your load balancing is your router. Acts as of your, like your router, it acts like your switch, where it gets all your data that's incoming traffic is all coming towards your load balancer, and your load balancer then acts as your router, where it could route different traffic to different servers you have. So you might have, please guys mute yourself. So you might have 10 different servers running on your cloud. One could be for user information, one could be for request, one could be as a database, and different kinds of service. And you'll have tens of and thousands of requests coming in. And as we saw before, instead of the routing now, where the router used to do the job of routing different traffic to different people, your load balancing will do that. We have something known as a virtual private cloud, where you could have your virtual cloud, and it's a private cloud where you could build your virtual private cloud instead of building. We saw how we had different networks before, and all of those different networks where you have local area network, wide area, all of those things, you could build that same thing using the cloud with something known as a virtual private cloud. We're gonna see how all of those works, and we're gonna get into the configuration part. But this is just to get ourselves familiar with what is the cloud and how, in contrast, how does the traditional IT sector works with the cloud. Now you'll have your servers, like we said before, on-premise servers, but then you would move into the EC2 instances. And your EC2 instances are, it stands for Elastic Compute, and that Elastic Compute is basically a computer, but instead of having a physical computer, you will have that computer in a virtual world that is managed by AWS somewhere sitting in one of those data centers. AMI is Amazon Machine Image, which sets the image, or basically how your computer will work on the cloud. So we know that once we get a computer, we get to install Linux, Windows, Ubuntu, whatever we want. We could install it. We could configure our computer on how we want it to work. On the cloud, once we have an EC2 instance running, there's something known as an AMI image, and we're going to get into that once we do the practicals. Oops, sorry. What happens is the AMI image, you get to choose an image. You could say, I want to run an EC2 instance using, let's say, for example, for the sake of example, we'll say AMI1 is Windows, AMI2 is Linux, Ubuntu. And then we will say, I want my server to run AMI1. So I choose the first image, and then my computer on the cloud will be running on Windows. And that's how I set it up. Or I could say I want it to run Linux, Ubuntu, and then I could say I would choose AMI2. Databases, talking about databases and storage, we saw how we talked about hard disks before. You could attach your hard disk to your EC2 using Amazon EBS. There's also something known as a Amazon EFS, which is file storage, elastic file storage, where you could share your storage in a file-based storage between different computers, different EC2 instances. So different, instead of think of it as using a one hardware external hard drive that is connected to different computers, where every computer has the access to that hard drive, and they could all access information, store information. And you could store information like that on the cloud by giving access to all of your instances, all of your cloud computing, or all of your computers on the cloud, which is EC2 instances. All of those will have access to the same file storage system. Then we have something known as the Amazon S3, or simple storage system, simple storage. That helps us with storing stuff in a file-based structure and in a bucket form, and we're gonna see how that works. Where you could store anything and everything on S3 file. We're gonna see how S3 is very helpful. One of the best things you will use on the AWS cloud would be your S3, where you could have a client-side web page completely hosted with S3, and then you have the backend running by Lambda or something, and you create a whole serverless architecture. And we're gonna see how all of that works, but these are just basic building blocks of the cloud. And then you have your relational database. People who know anything about SQL, relational databases, You could have your relational databases, your SQL, on the cloud as well, using RDS or Aurora. We're going to look at those as well. So these are the few uh, points we're going to take away from this section, which is
Can you
what
go
is
back for a second so I can take a picture of the last screenshot?
this one. You want to
Thank
take
you.
a picture?
Yes.
You don't technically need to take a picture. So if you go back, what I was showing you guys, if you go back here on your, go to the modules, and then you could go to the module 1, which we're covering right now. You would go into the student guide, and you will have the same lectures. So the same lectures that I have here, you will have it right here. So if I just keep forwarding this lecture right here, you're gonna see it right here. Okay.
Yeah.
So do not worry about taking pictures right now. All of you guys have access to it. All of you guys have access to those slides.
Thank you.
You're welcome. So we saw. So this first section we talked about few points. So the first point is cloud computing is basically your IT infrastructure, but on the cloud. It's on-demand delivery of IT resources. Think of it as your Uber Eats for computer services. You order it as you want and you pay as you go. So you don't pay for a whole EC2, you pay for the EC2 per second, per hour. So if I get a EC2 and I reserve it for 15 days and I use it for 15 days, I get to pay only for those 15 days. If I have a server running on the cloud for 3 hours, and I get to pay only for those 3 hours. Like we said, we took an example of saying if your customer base goes from 1 million to 10 million, what happens is you could increase your instances or your servers running on the cloud by a split second. So what would you do is you would say, if I hit a threshold of 800,000 customers getting into my system at once, then increase my servers to a capacity of 10 million. And then you will just go ahead and immediately increase it. Things like this could happen in a peak instance. So if you have a business and you have a holiday like the Christmas we had, you'll have a peak of customers coming in. When that kind of peak happens, your instances, you could increase them, and as soon as the holidays are done, you could bring that peak down again, and you would only have to pay those services for that period of 2, 3, 4, whatever days. That's what it means by pay as you go. So you only pay for what you use. You could use it for an hour, for a day, for a 2, for a year, for a 3 or 4, depend on how much you want to use, and you'll only pay for what you use. We talked about the 3 different models: the infrastructure as a service, platform as a service, and software as a service. And we saw how we could deploy them. There's 3 different ways we could deploy them. We could deploy them 100% completely on the cloud. We could have that deployment divided into on-premise or on the cloud, and then we could have it deployed on-premise using a virtualization form of the AWS cloud. So
Can you go over like 3 examples of infrastructure, platform as a service, and software as a service? Like just examples of each one.
okay, an example of infrastructure as a service would be your EC2. We talked about, if you go back right here on this image, you see how you have your EC2 instances here. This is your infrastructure. Before, you would have your infrastructure running on premise. You can see this on premise service,
Yeah,
and then
I get that.
yeah, and then you would have your EC2 running here.
Mm-hmm.
Okay, and
Yeah.
this would be your infrastructure as a service.
Because like a client doesn't have access to that. Only
No.
you as the solutions architect.
Yes, you as a solution architect will have that, and that's what are we doing here, because your client would not have this. Your client would actually only communicate with it, so you does not have access to it. Your client would send a request to it, just
Right.
like your client would send a request to your servers before. If you had a traditional servers in your server room or whatever place you decide to keep your servers at. You need something?
No, I'm just carrying
So instead of having your servers before, traditionally either on premise or however you want to have them, that infrastructure that you would have before, now that infrastructure becomes as a software, okay? Which
Yeah.
is the EC2.
Okay.
And then you'll have something known as a platform as a service, and that could be something as Beanstalk, which we're going to look at moving forward in the class, which
EBS.
is, I'm sorry?
EBS.
No, EBS is not a platform as a service. EBS is, it stands for Elastic Block Storage.
So it's
It
a
is,
software as service.
yes, these are software, these are actually your infrastructure as a service, because instead of having traditional hard disk and hard drives, you will have EBS or EFS or S3. These are your actual storage. You would use them, but your RDS, which is your relation database, that is your software as a service. Okay, so you'll have your storage is your different than your databases. So instead of having storage before, physical storage, hard drives, we covered all of those. So instead of having your physical hard drives, now you would have something known as EBS or EFS, and those are infrastructure
So
as a service.
basically, I'm sorry. So basically, the storage service, those are infrastructure as service.
Mhm. Those fall under infrastructure as a service because they will give you
Anything
the
that
infrastructure that you need as a service form. But moving to your database, to looking at something like Dynamo, RDS, and all of those will be your software as a service, because those are now offering you storage instead of because before you would still have your databases running on your servers that you have on premise, but now you would have them running on the AWS cloud.
Lambda is also software as a service.
And then you have your software as a service, and that would fall under things like CloudWatch, and we're gonna look at all of those things.
So just to
Look,
like
your
generalize, like anything that could be hardware is infrastructure as a service, and anything that is like, I guess, a software that can be
anything,
viewed
yeah.
as
So
like software as a
anything you
service.
would use, anything you would use as a complete software from end to end would be software as a service. So think of it like a good example for this would be your Netflix accounts.
Yeah, but like what services in AWS are like adjacent to a Netflix account?
You something known as CloudWatch,
CloudWatch. Okay.
CloudTrail. We're gonna look at those once we get deeper into the AWS. Okay.
Okay, and then what's like one of like platform? Like what's example
Platform
of
is known as a Beanstalk or
Beanstalk?
Light
Okay.
Sail.
Which one? What's that last one?
So you have something known called AWS Beanstalk. You have AWS Light Sail, and those
Like
fall
so.
under platform as a service. We're gonna
Okay.
cover them once we
All right.
move
Cool.
forward in the class. Okay.
All right.
I'm
Yeah.
just
Cool.
I want you to there are more than 230 different services provided by AWS.
Yeah.
We just want to understand how the cloud in general works, and
All
then
right.
we're gonna
Cool.
see each component.
All
Okay.
right. Perfect. Yep. Thank you.
You're welcome.
One quick question. So
Yes.
is there any glossary for the terms in this course? For example, those acronyms. So is there any glossary? Because
Yes. So whatever we covered so far, if you go to the student view, on the student guide on Canvas, you will see everything that they mention here. They will give you the full form of it. So here you have AMI, Amazon Machine Image.
Oh,
You
I
will
see.
have IAM, which is Identity and Access Management. You'll have EBS, which is Amazon Elastic Block Storage. EFS is Elastic File System. Simple Storage Service, your S3. You will have all of them once you go to the student guide. Okay?
Oh, got it. Yeah, great. Thank you.
That's why you should always go back once you at home. Always go back, read this student guide. These you will always want to read them before you cover your knowledge check. Okay? Because this
Okay.
is where you will get every little detail.
Okay, great. Thanks, Priscilla.
You're welcome.
Did you see a laptop?
No. Now we're gonna go into the next section of this, which is the advantage of cloud computing. And for that, there's a video we could watch, and then we're gonna understand more about what does it mean.
Hello and welcome. This video will cover the advantages of cloud computing. Why are so many companies interested in moving to the cloud? This section presents 6 advantages of cloud computing. Advantage number 1, trade capital expense for variable expense. Capital expenses, or CapEx, are funds that a company uses to acquire, upgrade, and maintain physical assets, such as property, industrial buildings, or equipment. You must pay for everything in the data center, whether you use it or not. By contrast, a variable cost is a cost that you can easily alter or avoid by using cloud computing. Instead of investing heavily in data centers and servers before you know how you will use them, you can pay only when you consume resources and pay only for the amount that you consume. Thus, you save money on technology. It also enables you to adapt to new applications with as much space as you need in minutes, instead of weeks or days. Maintenance is reduced, so you can focus more on your needs and the needs of your business. Advantage number 2, benefit from massive economies of scale. By using cloud computing, you can achieve a lower variable cost than you can get on your very own. Because usage from hundreds of thousands of customers is added up in the cloud, providers such as AWS can achieve higher economies of scale. That translates into lower pay-as-you-go prices to you. Advantage number 3, stop guessing capacity. Eliminating guessing about your infrastructure capacity needs. When you make decisions about capacity before you deploy an application, you often either have expensive idle resources or deal with limited capacity. With cloud computing, these problems go away. You can access as much or as little as you need and scale up and down as required with only a few minutes' notice. Advantage number 4, increase speed and agility. In a cloud computing environment, new information technology resources are only a click away, which means that you reduce the time it takes to make those resources available to your developers from weeks to just minutes. The result is a dramatic increase in agility for the organization because the cost and time that it takes to experiment and develop are significantly lower. Advantage number 5, stop spending money on running and maintaining data centers. Focus on projects that differentiate your business instead of focusing on the infrastructure. Cloud computing enables you to focus on your own customers instead of the manual racking, stacking, and powering of servers. Advantage number 6, go global in minutes. You can deploy your application in multiple AWS regions around the world with just a few clicks. As a result, you can provide lower latency and a better experience for your customers simply and at a minimal cost. Thanks for watching. We'll see you in the next video.
Okay, so we saw what is the different advantages of using the cloud over your traditional infrastructure or traditional setup for having computing power or servers running. So the first one is to you trade in your capital expense for variable expense. Now, for what does that mean? If we talk in a traditional sense, and you would have hundreds of servers running on the cloud, you would have to buy hundreds of servers. You would have to not only buy those hundreds of servers, you would have to buy the different components that will be dependent on those hundreds of servers. You'll have your routers, you'll have those bunch of things running. All of those you would have to buy them. Now, why do you want to buy them if you could rent a computer for 5 minutes if you want to do some kind of work for 5 minutes and then let it go? Now, if I needed to use a computer for 5 minutes, I would have to actually buy one, right? But in the cloud, I could rent one for that 5 minutes and get the job done, and then that's it. I don't need to pay no more, and I'm completely done with those servers. So that's what it means to have you. That's what it means to trade your capital expense, which is you actually having capital expenses on your business to buy and allocate servers for variable expense, where you could just have few instances running as you need them, and then that's what you need to pay. And it's again variable expense. Why is it variable? Because it changes as your need changes. So if I need today to have 500 servers, I will have them. If I need 1,000 servers the next day, I will have those 1,000. And the third day, if I want to go, I can go back to my 500 servers. That is very convenient and it's very variable. Now, if that needs to be done in a traditional sense, I would first have to get 500 servers, buy them, and then the next day when I need to have 1,000 servers, I have to go buy this another 500, come back, have them, and then next day I need only 500. Now I have 500 sitting around for me. So you would want to use variable expense, and that's one advantage the cloud has over traditional computing. Massive economies of scale. Now, as companies slowly but surely, everybody now, I believe about 80% of any new companies on the cloud, or 90%, I would say, are all on the cloud. What happens is, as more and more users join the cloud, AWS gets to reduce their price as they go, day by day, year by year. They will keep reducing because now they will have just huge base of customers and huge base of organizations just joining AWS cloud, and then they could reduce their prices as we go. As they go, each year they'll keep reducing, and that's how we as customers we will benefit, because now, just like we would have, think about it this way. If we had a company, if I started a company and I'm selling T-shirts and I have only 2 people buying T-shirts from me, I would want to have increased that little price margin a little bit, because now I'm having only 2 people buy from me. But if I'm having a million people buying my T-shirts, then I don't need to have the huge price margin. I can have a small price margin, and then I have a million people buying it, and then I could still make my profit by what? Having a huge customer base of a million people buying my T-shirt. So the same thing, the same idea is what helps us in the cloud. As more people join the cloud, we get to uh, save money by AWS reducing their price. Next advantage is we stop guessing the capacity. This is a very good image if you guys could look at this. So the first one says where your service is overestimated. Your capacity of your service is overestimated. You bought all of those servers for the first one, and you thought you're going to have all of those customers join your network. Next thing you know, nobody's visiting your website, and you have huge servers sitting around that you paid money for, and you're not benefiting anything out of it. Another example is you have so many servers, but you underestimated the capacity. Now you had 100, but next thing you know, there's a million people rushing into your you have a million people rushing into your website. That's why before we used to hear about this, that a website crashed. Now you will barely hear a website crash because of the traffic, because most of those websites are now built on the cloud, and those there's something known as auto scaling groups and stuff like that. We're gonna see how that works in a bit. But what happens is in the cloud, your servers go up and down. So if you could look at this third image, you could see the instances running. So you'll have, as there's a peak, you'll have more instances running, and then once you have the peak ends, like we were talking about, like after the Christmas sale, and your peak drops or your customer base drops, at that point, you could always come and drop it right here and have few servers running. And then as you have another peak, you could go up again, and then you could go down again, and that's how it helps. We scale on the demand. So we scale our services as the demand goes by. So once we have more people coming in, we have more servers. Once we have people go away, we stop using those servers again. Next thing is speed and agility. Now, if I wanted to, by traditional way of having servers, same thing, I would have to buy them, wait for weeks for it to get shipped, this, that, all of it to get launched, shipped to me, get it set up, configure them, everything. On the cloud, one simple click of a launch a new instance, and I have a whole new whatever number of servers I need running for me. And next thing is also it helps us by we stop wasting our money spending it on hardwares and stuff that could now in this day and age could be turned into a software. Instead of today me going ahead and buying a hardware and stuff like that, I could simply focus on putting that money into my customers, helping my customers some way or form, or developing my business somehow. We could also go global in few minutes. So AWS has many regions around the world. So they will have many regions around the world. They would have it in India, China, America, South America, Africa, Australia, everywhere. Now, in a traditional world, if I was having a simple application and I was running my application from Virginia, and I had my server sitting in my company's headquarters, and I have a customer that's sitting in Australia that wants to access my servers, there's something known as a latency. That latency is the time that the request travels to me, and the response comes back to my customers that's sitting in Australia. Now, if I one day and next thing I know, I have 10,000 customers in Australia, but I could not serve them very well like I serve my customers in Virginia, because the ones in Virginia, there's zero latency, not zero, but very low latency, and I could serve them quickly. And then the ones that are sitting in Australia, I cannot serve them quickly because there's huge latency, because all of those requests would have to go through the network. But now in AWS, I could simply have one server running here and one server running over there in Australia. And the one sitting in Australia could access what he wants with the same amount of latency between them. That's what it means by going global in minutes, because in the traditional sense, you would have to actually go open a branch in Australia. Today, I don't need to do that. I could just set up my account here. So these are the few key points, which is on this section. We trade in our capital expense for variable expense. We benefit hugely from massive economies of scale. As more people join, we get to pay less. We stop guessing capacity. We don't have to say, oh, I'm expecting a million users when I actually might get only 5. If I could say I'm expecting a million, but I actually get 100 million. So I don't need to start guessing no more. I could actually just focus on the actual work and let the AWS configuration take care of the load. And then the speed and agility, we could we can have an instance up and running in a minute, and I can terminate that instance in a minute. Moving forward, we're gonna look at we're gonna actually look at introduction to AWS. This was just the benefit of what AWS and everything in general gives us.
Hello and welcome. This video will cover Amazon Web Services. What is a web service? A web service is an application that is provisioned using the internet. We only concern ourselves with what type of data set we provision to the service in order to do its job, and then we worry about what data set the service gives us back as a response. The implementation details pretty much fall into an I don't care space. We no longer have to be concerned about the language or the platform in which the application is provisioned. So in general, a web service is a piece of software that makes itself available over the internet, or you can actually have it on your private network. A web service normally uses a standardized format for the input data set as well as the output data set. This format can be in extensible markup language, XML, or JavaScript object notation, JSON. This is the data set and the format that is used for the request and the response in order to interact with that web service through an application programming interface. It is not tied to the operating system. It is not tied to the language that was used to develop the software. It is self-describing using an interface definition file, and more importantly, it is discoverable. Amazon Web Services is a secure platform that offers a broad set, an ecosystem of web services. These products are basically delivered over the internet, and you have on-demand access to the compute, storage, network, database, or other IT resources that you might need for your projects and the tools to manage them. You can immediately provision and launch AWS resources in just a matter of minutes. The resources are ready for you to use very quickly. AWS offers flexibility. Your AWS environment can be reconfigured, updated on demand, scaled up and down automatically to meet usage patterns, and optimize spending. You can also shut them down temporarily or even permanently. The billing for AWS services becomes an operational expense instead of a capital expense. That means that you pay for what you use when you use it. AWS services are designed to work together to support virtually any type of application or workload. Think of these services as building blocks that you daisy chain and interconnect them in order to assemble quickly to build sophisticated and scalable solutions. And you can then adjust them as your needs change. AWS services fall under different categories, and each category contains one or more services. You can select the service that you want from these categories to build your solutions. Which service you choose to use will depend on the business goals and technology requirements of your application. Here are some compute options that you might choose to meet your needs. In terms of compute, we could use Amazon EC2 when you want complete control over your AWS compute resources and infrastructure. We will use AWS Lambda when you run code and not manage or provision servers. AWS Elastic Beanstalk allows you to provision a service that then deploys, manages, and scales your web applications automatically for you. Amazon Lightsail is actually a cloud platform for a simple web application. You will use it when you just want to launch a web application in a straightforward way. AWS Batch, you will use it when you run hundreds of thousands of batch workloads and you need to run them reliably. AWS Outpost, you will use when you want to run AWS infrastructure in your on-premises data center. If you want to implement a containers or a microservices architecture, you can use Amazon Elastic Container Service, Amazon Elastic Kubernetes Service, or AWS Fargate. We use VMware Cloud on AWS when you have an on-premise server virtualization platform that you want to migrate to AWS. There are also a variety of services for you to choose from in other categories, and the number of offerings keeps growing. The array of AWS services can be intimidating as you start your journey into the cloud. This fundamental course focuses on some of the more common and fundamental services. The categories that we will cover are compute, storage, database, networking, content delivery, security, identity, compliance, management and governance, and finally, cost management. You might wonder how to access the broad array of services that are offered by AWS. There are three major ways to access and create the ecosystem. The first one, the AWS Management Console. The console provides you a rich graphical user interface using a web browser to the majority of the services and features of those services. The AWS command line is a way of scripting your interaction with the ecosystem. The AWS CLI provides a suite of utilities that can be launched from a command script using a Linux operating environment, Mac OS, or even Microsoft Windows. If you're a developer, you can use a software development kit in order to interact with the AWS ecosystem. AWS provides packages that enable accessing AWS in a variety of popular programming languages like Java, C#, Python, Node.js, and others. This will make it easy for you as a developer to use the AWS in your existing applications. It also enables you to create applications that deploy and monitor complex systems entirely through code. All three options are built using a REST-like application programming interface. This serves as the foundation for AWS. Thanks for watching. We'll see you on the next video.
So that was the next section that we want to cover. We covered few. He talked about few points. So the first point is web servers in general are just a piece of software that is running on the cloud. So if I have a server running on the cloud to say hi to somebody as soon as they say hi to me, that could be an example. Or your bank is running a server behind the scenes on the cloud, where once you request or you want to send money actually, or you want to buy something, all of those are happening over the internet. And all of those little things that we do every day are happening in the internet. There's standard formats they use. It could be XML or JSON or RPC. So even RPC is being used. And the way those different servers or different services that are running on the cloud or different nodes, so always keep in mind that people use it interchangeably, words. So they might use, say, a service that is running, or they'll say, oh, a node that is running, or an instance that is running. Those words are interchangeably used. So do not get worried if you hear a new word like that. So what happens is the way that they communicate, just like two human beings would communicate, two services or two nodes or two instances would want to communicate using something known as a API. And APIs are used everywhere to do every little thing we have to do in a internet-based world. There's RESTful APIs, there's HTTP APIs, and there are different kinds of APIs that we will see. I'm not sure if we're gonna go cover them because we're not trying to cover programming here or development. We just want to see how the cloud system works in general. But the way you would have your two services communicate with one another is using API, and your API could be based on JSON, XML, RPC, or any format. Now, what does AWS do for us? AWS is a cloud platform where you'll have all your different cloud services, all your different needs based on the cloud. And that's the whole platform, which will gives you all the different tools you need to build huge kind of application or any kind of application on the cloud. We talked about it giving us on-demand access, because we said it gives you the payment plan was pay as you go. So that's what it means to have on-demand access to computing power, to storage, to networking, to databases, to everything we saw previously. We talked about in the previous slides. We saw how compute would move into the cloud. We have cloud storage, the different forms of cloud storage, networks, databases, and all of those are on demand. You pay as you go, and you get to have a new resource, or you get to allocate a new resource, maybe a new database or a new server or a new storage or anything. You get to allocate that on demand by whatever the demand need is, and you get to access it or allocate it or terminate it. That's why AWS offers us the flexibility. We said you only pay for those services as you need. Uh, and next thing is we want to understand those things we covered so far and those few points we talked about. They're all like few building blocks, Lego pieces. Those Lego pieces, you put them together to create a software, to create a architecture for application or a software, or anything to serve to solve a business need. So I might not even a software. I don't even might need to run a software. I could just run a logging system. I could run a notification system. I could run any kind of workload for a business need by using those building blocks, putting them together like Lego pieces to create an application, a software, or anything to have to meet my business needs. Now, these are the different categories of these services. So AWS has more than 230 services, but they all fall under different categories. You'll have, we talked about the ones in compute. We talked about the ones in storage. We talked about IAM, which falls under security. We talked about databases. Then there's other. We also talked a little bit about the networking and content delivery. But then there's a bunch of other categories. So you'll have VR, blockchain, game tech, mobile, media services, machine learning, IoT, all of different categories it falls in. So now just taking a look at this picture, you could imagine the wide range of different things we could build on the cloud by just looking at this picture. If I wanted to build a blockchain service, if I wanted to build my own cryptocurrency, I could simply host it on AWS. If I wanted to have a database, I could have it on AWS. If I wanted to do machine learning, I could do it on AWS. If I wanted to have robots running around, I could have my robots, softwares, and things running on the cloud. If I wanted to have games, everything I could build, anything I could imagine on the cloud today. So these are different categories of the services that they have. Now, under each category, there's a few different things, and I think that's in the upcoming ones. But here we can see. So this is a simple example. So we could have something set up like this, where we have a virtual private network, which is like me having my local area network. And in it, I will have my EC2 running, which is my computer or my server. And in that, I could have my storage, my S3. And then in there, I could also have my DynamoDB, which is another kind of database. We talked about RDS before. DynamoDB is a NoSQL database. And then this is how you could have a simple solution. So before, you would have to have network, but now your network is translated into a VPC. And then instead of having a compute power or CPUs, basically your compute power, where you have input output, You could have all running on a EC2, and then you could have your databases for DynamoDB or RDS or Aurora. There are different kinds of databases on AWS. And then you'll have your storage as S3 or EBS or EFS. We saw those. Now we're gonna look at more complicated structure or architecture of how to have event-driven systems, or maybe a monolithic architecture, or layered architecture, or serverless architecture. We're going to look at more complicated, so do not worry about this. You're going to see very complicated. But as we go forward, it will get easier. So this is a simple solution, and as we move forward, we're going to get a little bit complicated, but we're going to think bigger in a bigger picture sense, and then we're going to solve huge problems by putting those little services that AWS provides together and like Lego pieces and creating a solution.
Can you repeat that section that you just did again?
This one?
This one. Yes, the second section.
So this is a simple solution, and this is just an example, okay? This would help us think in a traditional sense. What I would have to do, okay, in a traditional sense, I would have a network running, and that network would be my home network or my company network or something. And then on there, I will have services running, servers running. And then on that, I would have storage, which is all connected to my storage connected to my servers. And then I will have databases where I will store my data. Now, and simply to take that simple structure where we would have in a traditional sense, in a cloud, it will be running using these services. So I could put in my networking, which is under the networking, I could have our VPC, and then under our compute category, I can have my EC2 running, and then I could have my DynamoDB as a database, and I could have the storage, S3 as a storage instead of a hard drive or something. And I could connect all of this together and create a simple traditional sense by using 4 different categories. And that's how they all come together. Because here we talked about in the previous slide, we talked about the different categories that the different services fall under. And now all of those different services, we want to take them like small Lego pieces and put them together to create some solution. And here is a simple solution for a simple web server that is running on the cloud by using 4 different categories, and under each category we have one service running, and that's how we put it together. But we're going to see more about this and how they come together as we move forward, as we go into the architecture class.
And
that's how we. I'm sorry?
In the on-prem, the EC2 service will be your server, and then let's say this Dynamo DB, let's say it's a SQL, that will be your SQL server, and then the
I'm sorry, could you please repeat that?
Yeah, sure. I said in a hardware environment, right? That Amazon EC2 server, that will be like your actual server, your physical server, and then the DynamoDB, that will be your SQL server. Database server, and then the Amazon S3 will be like your NAS storage.
Right.
DynamoDB is serverless. It doesn't have SQL.
Yeah.
It's a different one.
Yeah. This is just an example. It could be we could easily and simply substitute DynamoDB here for a RDS. So it does not matter. This is just this is an example, okay? So it could be no SQL, it could be SQL, depending on the business need, actually. But this is just an example, so we could see how those different services comes together to create the end solution. Okay. So we saw the simple example of how to put those services together to create a solution for a given problem. But we're gonna see how those work uh, in a bigger problem kind of scenario where we'll get to creating those solutions. Now, uh, to choosing a service, we get to choose our service depending on the business need. So we could either go from a compute service, completely computing service, to AWS Lambda. We're going to look at that, which is a function on fly, which is basically a function to run without a server or a compute resource running. We're going to look at all of those different things. And then we have Beanstalk and Lightsail. These are deployment platforms. These fall under the platform as a service. We'll have Beanstalk and Lightsail, where we could launch applications. So you could launch a huge application from by using Elastic Beanstalk by simple configuration. Lightsail is used for a simple web application or a web page. And then to run workloads, we have AWS Batch. Then we have AWS uh, Outpost for on-premise workloads. Fargate to run and manage containers. EKS, Elastic Kubernetes Services. People who are familiar with Kubernetes. Is anybody familiar with Kubernetes container services?
No.
Should not be. Yes. I'm sorry, the people online, somebody said something?
No.
Not me.
Okay. So containers are where you would have your computer, you'll have your computer running and it will be running a container service. And then you could have multiple containers on top of that one container. It's like a hypervisor for the people who were with us in the fundamentals class. It's like kind of like a hypervisor, but in your hypervisor, you would have to actually divide up your computing power, your CPU. Here, you would have to, your CPU and everything would be running, will be managed by the container service. And then on top of that, you will have multiple containers. You will have something known as Docker, Kubernetes. We're going to look at those once we move in deeper into the class. Do not worry about that. So the Fargate, EKS, and ECS, they all fall under containers. And then VMware Cloud, that is also for on-premise to connect it to the cloud. And we're going to look at all of those in depth once we move forward. Like we saw earlier, so here earlier we saw the different categories of those services. Here are a few services under each category. We're not going to go into each category. We're not going to go into the blockchain, business application, or stuff like that. We're not going to go into analytics, IoT, but we're going to go into few of those categories, and under each category, we're going to look at a few services. Like we said, there's more than 235 services on AWS. We're not looking at all of them, but we're going to look at some of them. I cannot even say half because half would be more than 100. So under the compute service, we're going to look at EC2, Lambda, Elastic Beanstalk, and then we will have auto scaling groups. We're going to see that ECS, EKS, ECR, which is container registry, Fargate. We'll look at all of those. Under security, we'll have IAM, Cognito, Cognito. Somebody. Excuse me. Give me 1 second, guys. People online. Hello. Sorry about that. All right. So we have under security and identity management, we have few services. We're gonna look at them, and then under storage, we have S3, S3 Glacier, EFS. We will look at those, and then database services. There are multiple. There's RDS, Dynamo, Aurora, Redshift, networking, Route 53, which is your DNS service, CloudFront, which is a CDN. People who are familiar with CDNs, CloudFront, Elastic Load Balancing, which is acts like a router for you guys, and then you have your VPC, and then management and governance services will have Trusted Advisor, which helps us to, which will advise us on what is the best way to do something. Uh, do you have CloudWatch, CloudTrail, auto scaling groups, command line interfaces, and bunch more. So management console, we're gonna look at all of those different things. Now, how do we? Next question comes: how do we actually interact with the AWS services that we have? So once we have our services running and we allocate services, we could connect with them three different ways. The first way is to use the management console. Uh, to use the management console, you will log into your management AWS account using Google Chrome or something. That is the management console.
Lost your
Uh,
sound.
the audio just.
I can't hear you. You accidentally muted yourself.
I'm sorry. Okay. Uh, okay. Uh, so I was saying, what are the different ways to connect to our AWS accounts or services that we have running? There's three ways. We can connect using the management console, which is a graphical user interface. And those is you can simply connect to those by logging in to your account. So this is your management console. So once you go in here, all right, is the internet not working? So this is going to be your management console, and you could simply go ahead and connect it this way. And then once you have this is how you connect to the console. And this is your graphical user interface. We're going to look at those once we move forward in the class. And then you'll have your CLI. Your CLI is your command line. We saw earlier how to use a command line. The only difference is that we will be using the same command line. Oops, sorry. We will be using the same command line, but the only difference is this time we'll get into SSH and SSH keys. We will have SSH connection to our servers, and then we could interact with them or access to them using our command line. Then next thing we have is our SDKs. Our SDKs is software development kits where you could have different access to different services by using code. So once you are a programmer or a developer, you will mostly work with a SDK. An SDK could be for Python or Java, or for JavaScript, which is a Node.js SDK. All of those SDKs will available, and you could get them depending on what you're using. So if you're using Python, you could use pip. If you're using Node.js, you could use the npm package manager, and that's how you get your development kits, SDKs. And we're gonna see how those things work once we move forward in the class. So those are the three ways to connect. And in this section, the three things, the 4 key points we want to take away from this section is that AWS is a global cloud architecture platform where you could build global architecture solutions for your business needs or softwares or applications that you're running. There are many categories we saw. There's compute, there's networking, there's identity management, there's databases, there's much more. There's blockchain, there's different kinds of things. We choose services depending on our business needs, and whatever need we have for our business, that's the one we go with. And then there's the 3 ways that we connect to our AWS services. Moving to the next section, which is a cloud adoption framework, which is a white paper, and we're going to see what that means in a bit. So let's get into a video, and then after that, we're going to go ahead and go through those slides over once again.
Hello and welcome. This video will cover moving to the AWS cloud using the cloud adoption framework. Cloud computing offers many advantages over the traditional model. However, for most organizations...
Sorry, I heard somebody. For the people online, could you guys please mute yourself if you do not have a question?
Cloud adoption does not happen instantly. Technology is one thing, but an organization also consists of people and processes, and these 3 elements must all be in alignment for successful cloud adoption. Cloud computing introduces a significant shift in how technology is obtained, used, and managed. It also shifts how organizations budget and pay for technology services. Cloud adoption requires that fundamental changes are discussed and considered across an entire organization. It also requires that stakeholders across all of the organization's units, both within and outside information technology, support all these new changes. In this video, you will learn about the AWS Cloud Adoption Framework. This is a document created to help organizations design and travel an accelerated path to successful cloud adoption. Each organization's cloud adoption journey is unique. However, in order for any organization to successfully migrate its IT portfolio to the cloud, 3 elements, that is, people, process, and technology, must be in alignment. Business and technology leaders in an organization must understand the organization's current state, target state, and the transition that is needed to achieve the target state so that they can set goals and create processes for the staff. The AWS Cloud Adoption Framework provides guidance and best practices to help organizations identify gaps in skills and processes. It also helps organizations build a comprehensive approach to cloud computing, both across the organization and throughout the IT lifecycle. This will accelerate successful cloud adoption. At the highest level, the AWS Cloud Adoption Framework organizes guidance into 6 areas of focus called perspectives. Perspectives can cut across people, processes, and technology. Each perspective consists of a set of capabilities, which covers different responsibilities that are owned or managed by cross-functional teams. Capabilities within each perspective are used to identify which areas of an organization require attention. By identifying gaps, prescriptive work streams can be created that support a successful cloud journey. In general, the business, people, and governance perspective focus on business capabilities, while the platform, security, and operations perspective focus on technical capabilities. Stakeholders from the business perspective, that includes business managers, finance managers, budget owners, and strategy stakeholders, can use the AWS Cloud Adoption Framework to create a strong business case for cloud adoption and prioritize cloud adoption initiatives. Stakeholders should ensure that an organization's business strategies and goals align with its IT strategies and goals. Members within the people perspective, like human resources, staffing, and people managers, can use the AWS Cloud Adoption Framework to evaluate the organization's structures and roles, new skills and process requirements, and identify gaps in them. Performing an analysis of needs and gaps can help prioritize training, staffing, and organizational changes to build an agile organization. Stakeholders from the governance perspective, for example, the Chief Information Officer or program managers, enterprise architects, business analysts, and portfolio managers can actually use the AWS Cloud Adoption Framework to focus on the skills and processes that are needed to align IT strategy and goals with the business strategy and goals. This helps the organization focus on maximizing the business value of its IT investment and minimize the business risks. Stakeholders from the platform perspective, for example, the Chief Technology Officer, IT managers, and solutions architect use a variety of architectural dimensions and models to understand and communicate the nature of IT systems and their relationships. They must be able to describe the architecture of the target state environment in detail. The AWS Cloud Adoption Framework includes principles and patterns for implementing new solutions on the cloud or migrating on-premises workloads to the cloud. Within the security perspective, members such as the Chief Information Security Officer, the IT security managers, and IT security analysts must ensure that the organization meets security objectives for visibility, auditability, control, and agility. Security perspective stakeholders can use the AWS Cloud Adoption Framework to structure the selection and implementation of security controls that meet the organization's needs. The operations team members include IT operations manager and IT support managers to define how day-to-day, quarter-to-quarter, and year-to-year businesses are conducted. Stakeholders from the operations perspective align and support the operations of the business. The AWS Cloud Adoption Framework helps these stakeholders define current operating procedures. It also helps them identify the process changes and training that are needed to implement a successful cloud adoption. Thanks for watching. We'll see you in the next video.
Okay, so the AWS Cloud Adoption Framework is not something we are gonna go into depth with in this class because this is not technical. This is just a white paper. This is a guideline to companies and enterprises when they want to move into the cloud. How would they move into the cloud, and what are the different players, stakeholders, and people who are concerned, and what they need to be concerned with. So you will have, under the Cloud Adoptions Framework, you'll have the 6 core perspectives: people, business, governance, platform, security, and operations. And so these different things three should focus on the business capabilities, and three should focus on the technical capabilities. Business perspective, you'll have your business manager, finance manager. All of them have to know what is the business need and develop a business case for adoption of the cloud. So why should we move from traditional to a cloud infrastructure? Now, these people now that are all going to be, if they decide to move forward with the cloud, how are the human resources, staffing, managers all be trained and everything? Now, the governance is how the program managers, portfolio managers, and all of those people get their strategy aligned with the cloud and how to maximize the business value of it. And you'll have your platform perspective, where you have the CTO, technical officers, solution architects, and people. And this is where we want to actually learn about what to do with the cloud. We're not going to be going into the nature of how different people need to communicate and understand what are the different things we need to adopt. We want to just learn about how those systems work. We want to learn about how to become a solution architect. And we don't want to get into each section of it because we are here to learn how to become solution architects. And then you'll have your security perspectives. You will have your IT security managers, and your security analyst or CSISO. They need to meet and they need to ensure how those security objectives will be achieved. And then your operation perspective, how to day to day, quarter, year to year, how that needs to be aligned and how those needs to be achieved once we move to the cloud. But this is just a white paper, a guideline for any company that wants to move forward in the cloud to use. Uh, that's for section 4. We don't want to spend too much of our time in section 4 because this is just a framework to follow once we want to move forward into the cloud. But now to wrap up this first module, we covered the types of cloud computing, the advantage of cloud computing. We also saw the service categories and core services under few of those categories, and then the adoption framework. But do not bog yourself down with the adoption framework because that's just a guideline of if you want to move into the cloud, how should you move to the cloud? And that's talking in general sense of a whole enterprise where you have all the different players from your analysts to your managers to your business stakeholders and everybody, how they need to be involved. But we are going to only pay attention to how to become software architects or solution architects, and that's what we're going to look into in depth of this question. Now, you will have your knowledge check after this, and I want everybody to go into the knowledge check of the class. And if you guys go in here, so once you go in and you watch all your videos and you go all through all the lectures, you could just click next, and then you'll have your wrap-up video. And then after your wrap-up video, and if you go in next to all the way to this is your student guide, but then you could go into your knowledge check here, which is 10 questions, is not much. This has 10 questions. You could take it as many times as you want. You have to score 70% or higher. And I want everybody to go through this because this is where I can track everybody's progress and I can know how people are doing. So I really recommend you guys to go through this. And once you guys go through this, I can see and track everybody's progress. And we can know where everybody stands. And then we understand how people are doing in the class and what people are, where we should focus on more, or what should we not focus more on. So, and this will also help you guys to know how well you're doing in class. So please go through the module knowledge check. It's just 10 questions. Take them. Once you take them, we will see how every student is doing in the class. We spend most of the day today getting into the setup and everything, but everybody should be set up now. Moving forward, we're not having any more students join the class. And we're gonna now move quickly forward through the modules. Not quickly, but we're gonna cover all those modules and move through them. So we could, at the end, go to our solution architect class. I know there are a lot of people online, like Kunti and Chi and all of those people. They've been with us for a long time. They all been waiting to get into the class. So we finally started, and yes, so just have patience and we'll move forward with the rest of the modules. So what I want you guys to do is for a homework or an assignment is please read the first module, uh, then take the knowledge check, and I'll see how everybody does. And you could also then after that go into your second module, read about it, and get an idea. But once you get into the second module, try to get an idea of the second module, which is again just the how does the cost of AWS work? How does the billing service and the cost and pricing works? Nothing too technical. We're gonna quickly go through it in the next class, and then we're gonna go into the even the infrastructure.
Sorry to interrupt. I think up to module 4, it's everything is not too much technical.
No, model 3 is where model 3 will start kind of technical because it will tell you your different places and where it's located and how to have different services. But most of the technical stuff will start in module 4, which is the cloud security.
Because after that, the labs or everything is starting.
Yes, so only after we get to here, we're gonna have so this is the first lab we're gonna have. Okay, so module 4, and we will cover this in next class. Actually, Wednesday, we're gonna quickly cover module 2, 3, and then we're gonna go into 4. We're gonna go do our first labs on module 4 in next class on Wednesday. Okay. But go ahead, guys. Go through this one, read about it, because we're gonna quickly cover 2 and 3 in the next class, because it's not much technical. So this was an introduction to the cloud today. Now we'll see how the cloud actually works moving forward. And I can show you. We want to get into a level of AWS serverless diagram. If I could see something like this, we want to go into more complicated diagrams, how we would want to use that, all of that put together. We're going to move into more forward different architectures like this. And we're going to see how all of those different things work out. Okay? So that was just an introduction to the cloud today, and then we're going to move forward and we're going to see how all of that comes together.
So module 1 and 2 is pretty much the homework.
Module 1, read about it, your knowledge check. Module 2, if you guys could cover the knowledge check on module 2 also, that would be good. But if not, do not worry much about it. Just read about it and know about it. But we're going to cover them in the next class. So, but the homework is mostly your module 1 knowledge check, so I could see how everybody's doing from the day 1 of the class. But then once we move forward in the next class, we should cover 2 and 3 quickly. Then we want to move into module 4, where we would have our first labs, and we're going to see how the identity works.
All right, perfect.
Okay.
So that'll be
what about the
next Sunday?
No, Wednesday. We have our classes on Wednesday and Sunday. So Wednesday at 7.
The next labs that we do, like when we start the labs, it'll be on Sunday.
Monday. Wednesday.
Oh, we're starting the labs on Wednesday. Okay, cool.
We're gonna start the labs on Wednesday. So we have a 3-hour class on Wednesday. Hopefully we cover module 2 and 3 in the first hour. And then for the next 2 hours, we want to do probably 1 hour of covering the theoretical part of module 4, and then the last hour maybe do the labs for module 4.
Hey, Mustafa, one question. So, is it to me, it seems that the strenuous jobs of this course is basically on Wednesdays, which is the night class, which is 7 to 10 p.m.
No.
Is
So
it
this is
possible
only
to shift it to, like, because I am not very productive in the night. So if you want to go over 2 modules, and the homework will be on Wednesday, so it will be a lot of You know what I mean? Would it be possible, to put more of those kind of things on Sundays rather than on Wednesday, which is like late in the night? That's
No, so
my opinion.
yeah, so moving forward, everything, so it's just the first three modules. After that, everything else is technical. And so we're gonna have technical stuff Wednesday, Sunday, both days. Okay?
Oh, I see.
So
Yeah.
the technical stuff will be both days, both the classes. Just this is just getting us ourselves started. So the first three modules is just getting started with what is the cloud, what how do we use the cloud, and what are the different settings for the cloud, and that's about it. But then after that, everything is technical. Okay.